Hello, good morning, good evening, good afternoon. Welcome everyone to our fourth and for the moment last edition of our IBM Tech Talk series with ConSol, a cloud native story. Today we are going to talk about an introduction to service meshes. So we are very glad you are here with us today. My name is Marion. I'm part of the developer advocacy team here in Germany and I'm from Berlin. I'm really eager to read where you are joining us from, so please tell me in the chat. I'm going to monitor this. And for all of you who have not been able to attend our last or previous sessions with ConSol, I will post the links in the chat just in a minute, so you can actually have a look at the replays. It's worth a watch. Today, I have Olaf Meyer with me, and Olaf already has a long history with IBM, actually. He's part of the OpenShift DevOps team at ConSol, and he actually considers himself to be more on the dev side of it. So I'm really excited, Olaf, for you to give us an introduction to service meshes and how to actually deploy one of the most popular ones, Istio. But before we jump into the sessions, I would like to say a couple of words about IBM Developer and the Crowdcast platform for all of you who are actually new to our series and our sessions. IBM Developer is IBM's initiative to reach out to developers in the ecosystem of partners, clients, and the community like you. And we do that based on three very important pillars: code, content, and community. We cover a lot of topics around hybrid cloud, AI, open source, and many other new technologies. So regarding the code, you can find a lot of code examples in form of code patterns on our website, developer.ibm.com. So if you haven't had the chance, take a look at the site. It's really a lot of examples on there. And with respect to content, all of our developer advocates are very constantly writing blogs, creating videos, how-tos, and they are also either on the developer.ibm.com site or on their personal blogs. And I'm going to post a couple of examples in the chat just in a second. And this actually brings me to our last pillar, the community, which is you. We do accompany all of the digital content we are creating by face-to-face events like the one today. And you can find our most important and most recent activities on our Meetup platform, IBM Developer. I'm going to post the link just in a second. So please, if you haven't joined our community, get in touch with our developer advocates, with our senior matter experts, and take a look what's going on in the next couple of weeks. So last but not least, one more word about Crowdcast. If you have questions, please put them in the Ask a Question section, so I can make sure your questions are really getting answered, because sometimes if the chat is too crowded, we might miss a question. So put it in the Ask a Question section. I'm going to monitor both of those. And please feel free to be active to comment in the chat. And with all that said, hello, Olaf.
Hi.
The stage is yours. I'm going to give the stage to you, and I'm going to go on mute.
Okay, so let's share the screen. This one. Share, and here we go. Can you see my screen or the presentation?
Yes, we do.
Great. So thank you everybody for joining. I'm going to give a short introduction to service meshes, especially to Istio. I try to my very best to limit that to 45 minutes, but it might be that I take a little, or that it takes a bit longer. So let's start. Who am I? I work at a company called ConSol. I started working in IT about 20 years ago, and my first steps were really with Lotus Notes and Lotus Domino development. So yeah, like Marion mentioned a long history with IBM. Currently, I'm focusing on OpenShift, Kubernetes, and try to help customers to build to move their application either to the platform or to build them on scratch of the platform. And I really like to focus more on the development part. So what I'm keen about is how to reduce the cycles for the developer to run the application. So everything that comes before the CI/CD part. And this is one part that I'm going to talk about a bit later in the example. So let's just give a small part, or let me talk a bit about ConSol. ConSol is a rather old company. We were founded in 1943, 48. We have a big team which does software engineering. So we build software, maintain software, and so on. And also we have one part one company, department which does the operations part. So not only do we development, we do operations as well. We have our own small or big product, the ConSol CM for handling tickets. And I'm in the IT consulting part. So if you have any question, you want to deploy something on OpenShift, just give me a shout. So let's go to the agenda of the talk. So I will have 5 points. The first one will be when and why to use service meshes. What's the reason behind that? Then I will talk a bit about what is Istio. Why do I mention Istio all the time here? What is Istio Workspace? Then I'm doing a short demo about Istio Workspace and Istio in general. And then we are going to wrap that up. So let's start. I'm coming from the middleware development area. I've done quite some development with JEE applications in the area of REST gateways, middleware, and so on. And from my background, what happened is if you look at enterprises, usually you will have some front-end application. You might have some middleware, and you have some back-end systems that could be either some logistics, custom relation management, ERP, GIS, or whatever. And they are all connected in some manner. So if you have microservices, you might talk directly to the backend. If you have more like a classical way, you might want to have a middleware which consolidates some information, reduce or filters something, aggregates some information or whatever. But what's happening if you look behind the scenes, you see that not everything is as clear as you would like to have it. Like here, you have everything very easy, very streamlined. But if you look at the reality, it looks more like this. So you have a front end which is talking to logistic systems because they need to give a customer a very quick answer, and the REST gateway or the ESB might be too slow for that. You have the mobile application which accesses the geo-information systems directly and not using the REST gateway. And you might have some reporting applications which were introduced by the management because they paid some companies some money, so that they get a report from all the applications that they are able to connect to get an idea for sales what kind of campaigns they should start on, and so on. So that means that if you take that infrastructure, you have a lot of points that you aren't aware of. And if, for example, the logistic goes down, it doesn't help you if you just have a resilient REST gateway, but the front end might be directly impacted. And if you try to run that in production, usually you will get some requirements from the application operation teams or now from the DevOps who are saying we need some cross-cutting concerns to be in place. And mainly these cross-cutting concerns can be grouped in 5 points. So one would be to have a visibility and reporting so that you know which application is talking to which application. Here's that you can get some metrics to see how long does it take from a request to go in from the front end to the back end, and that you get an answer. You want to have resilient and fault tolerance. So if some backend goes down, you want to make sure that your web page still works. Maybe you show the customer some small information. You can't get that part of the application, or you can't see that part of the application right now, or of your data, but you can still place orders, watch your order history or something like that. So you really want to make sure that a customer, the overall experience isn't that impacted as much as possible. You might want to play around with new versions to introduce some A/B routing to have a better traffic control, so that the connections are created with certificates that you use SSL for HTTP connections. You want to apply authentication and authorization so that you know which application is talking to which, that you have the proper permissions. And last but not least, you really want to enforce it. So it's a difference to tell, I would like to have that, in contrast to, I really enforce that we use SSL for the connections between the application. And this really started, there were some frameworks introduced, and one very popular was one from Netflix, or at least in the Java area, which meant that you have your business logic and you extended it with additional like cross-cutting concerns for service discovery, load balancing, monitoring, tracing, and so on. And of course, these cross-cutting concerns meant that you needed additional server components as well. So each of the config server, traffic control, and so on meant that you had an additional server that you needed to maintain, update, and so on, which is some additional effort. And depending, could be much more. And you not only had that in one application, but you needed to have that in all of your applications to really to have an overview of all your complete environment. So each application needed to have a framework included for monitoring, for tracing. They all needed to talk to this same server, and you have to make sure, of course, that they are high available, because it doesn't make sense that you have a monitoring solution which lower availability than your application, because then you don't know if your application is still up when your monitoring solution is down. And this can become quite challenging if you use different frameworks, different approach like reactive programming or different programming languages. So everything that you find with Java might work for your Java environment, but if you use .NET, Python, or whatever you might choose for a certain environment, then it can become quite hard to cover these cross-cutting concerns, to use the same API, to send the same requests in a same manner that the servers can understand it and that you can maintain and use that. And I think the hardest part is if you bought some software. So if you have an SAP or other CRM or ERP solutions, it's really hard to integrate them and to use these kinds of requirements for them as well. And just as a small reminder, this is how our infrastructure looks at an example. And it doesn't mean that, for example, the ERP or GIS system is just one monolithic application. So you might have a monolith, but that doesn't mean that you not have multiple installations of it or multiple deployments of it. So you could have a lot of applications where you need to add the cross-cutting concerns to the source code, and that could be quite a lot of work. So because of that, there was a trend to use something like we had with Java with aspect-oriented programming to pull the cross-cutting concern out of the business logic. And since more and more parts are used in containers, the cross-cutting concerns are also moved to container, which leads to an architecture like this. So you have your application with your business logic in one container, and in front of it you have a proxy, and the proxy will get all the requests that are going to the application and that are coming back to the from the application. So it's really all the requests are going through it, and that applies to all the applications that are in a service mesh. Which means that if you set up the environment like that you don't need to have the additional frameworks in your application. You just need to configure them for the proxy. And configuring to do that for larger environments could be quite hard. So here we have a separate component called the server mesh control plane, which means here this is the interaction part where you as a developer or as the end user are connecting to. Here you put in your configuration where you define that you would like to have the requests from application A to application B encrypted, that it should be secured via, for example, a mutual TLS. And the nice thing about that is your application or your business logic doesn't need to know that your connection is encrypted with SSL. It just knows that it wants to talk to the other application and how the data is transferred and which protocols are used and how it's if it is encrypted or not. That's part of the proxy implementation or configuration. And since you are pushing all the information to the proxies from the control plane, it also means that the proxy itself knows a lot about how much a request takes from the left-hand proxy from the left side proxy to the right side proxy, and how long it took to the response to get back to the left side application. And with this, you can transfer the telemetry data back to the service mesh control plane. And the upper part is called the service mesh data plane. So this is really where the data is moved. So we have the control plane, which contains or which configures how the proxies are set up. And you have the data plane. This is where the application and the proxies are configured. And the nice thing about that approach is you don't need to change your application code, or for almost all scenarios, you don't need to change your application codes. So if you want to do some changes for the retries or for the encryption, you just need to change the configuration in a certain environment, and then the configuration will apply and the code is still untouched. Just as a quick side note, the popular service meshes are, or the most popular is Istio. From the part where I work with OpenShift, there is a Red Hat implementation for that, which is called OpenShift Service Mesh. Linkerd is very popular, and ConSol Connect as well. And almost all cloud providers and API gateway providers or manufacturers bring their own service mesh. So you find today a lot of service meshes, but if you look under the hood, a lot of them are built on top of Istio. And if they are not built on top of Istio, they use the same proxy that's used as Istio as well, because Istio is using Envoy, and you find a lot of service meshes that are built on Envoy. Okay, so Let's go to the next point. That would be, what is Istio? So Istio was built in the Kubernetes environment. And like a lot of things in the Kubernetes area, it has something to do with sailing or with oceans and so on. So Istio is Greek for sail. And the aim is to provide a platform-independent service mesh for traffic management, policy enforcement, and telemetry collection. And from what I see, Istio is used very heavy on Kubernetes-based distributions or clouds. But you can, for example, use a VM and put a proxy in front of it and add that to a data plane. That is still possible. So it's not like Istio is only focused on Kubernetes, but it allows you to use VMs, bare metal machines as well, and to use to add their proxies as well, and to add them to a service mesh. The architecture from Istio is very similar to the one that I showed before with the control plane and data plane. It has some differences. One of the key differences is it has specific proxies for incoming and outgoing requests. Incoming means into the service mesh. So here we have an ingress proxy, which contains certain checks which would terminate, for example, TLS connections, and also verifies that for certain endpoints, JWT token is required, and so on. The same or something similar is happening for outgoing connections. So you can enforce with Istio that all outgoing connections are routed through an egress proxy. And the egress proxy will take care that you provide the correct authentication to whatever system you are talking to, and that you use the correct certificates or MTLS connections or certificates. Within the control plane, so that would be data plane, sorry, the upper part, you will have a pod, like always or almost always in Istio and Kubernetes. So you have your application container running, and as a sidecar container, you will have the proxy. And the proxy is set up in that way that all the traffic is going through that. And how the proxy is configured is done with a control plane component called pilot. So the proxy is really taking care that if you want to talk from a pod of service A to a pod of service B, that the connection will be secured, that you have the proper certificates attached or used in that connections, and also that the service discovery will take place and that you are allowed to use that service B if you reach the proxy. So it really makes sure that all these things happening, and the control plane is there to provide the configuration, which is done by pilot. You would have the citadel for the certificate. And in the previous versions of Istio, you had an additional component called mixer, which was there to provide the policies for more complicated checks and also fetched the telemetry data. Currently, that diagram that I'm showing here is not, or how to say, the components are still there, but Istio moved away from to have multiple microservices with different pods to one pod, which is called IstioD, that I can show you on later. So you still have the components, but they moved away from microservices, so to say, back to a monolith. And from what I understood is the main reason was that the components are that tightly coupled that it doesn't really make sense to have a separate deployment, but more, it's much better to have just one component running. And yeah. So if you use Istio or you want to have service meshes, typically what I've seen what you use is you might just want to use that to create secure connection between pods. Because to create an SSL connection is not that hard if you put the certificates in the correct placement location, then you can create SSL connections. But from an operation point of view, you have to do a lot of maintenance work to make sure that the certificates are still valid, that they are created with the correct CA, that the client knows that CA, and so on. And it gets more harder if you use mutual TLS, meaning that you have client and server certificates, so that the server has only a limited number of clients that will talk to or accept requests. And that makes it really hard. But if you use Istio, then that could be just one configuration to tell them, in that namespace, I require to use TLS or MTLS, and then all the connections will be secured with MTLS. Another part is authorization and authentication. Not so much that you use specific authentication token like JWT token, but that you make sure that only pods are allowed to talk with each other based on specific conditions, so that pod A can only talk to the get method of pods from service B, and is only able to do that if a certain request header is set. So you can really have a fine configuration possibilities how to set up which pod is talking to which pod. And this is beyond the scope that, for example, you could do with network policies from Kubernetes. Another part is it's very easy to implement tracing, because if you connect all the services together with the proxies, then you can, of course, gather some tracing information. And this is the part where you might need to do some implementation so that you can correlate incoming requests with outgoing requests, so that, you know, if service A gets a request, then service A will create a request to service B, and you might need to add some configurations there, that certain headers for HTTP will be tunneled through or will be used in subsend requests. The last 2 points would be that you have some kind of traffic management, which is very easy. So you can define, I would like to do an A/B deployment, and 10% of the requests are going to a newer version, and the majority is still using the old version, so that you can do either A/B tests or canary deployments. And what I find a very cool feature is to use dark launches, meaning that you are able to duplicate the traffic or mirror the traffic to a newer version, but the response of that newer version is not sent back to the client. And this can be helpful to see that if a newer version behaves in the similar way like the old version, has the same kind of performance settings, or that certain bugs really don't happen before you are going with something live. So the user will never see that requests that are processed by a newer version. And last but not least, you can get an overview based on the real requests that are happening within a service mesh. And this is something that I'm going to show you in that demo later. Okay, so far for the rough introduction to service meshes. Usually what Now what happened is that I would start to show a demo how you could do traffic management with Istio, that you can split the traffic between two versions, how you can implement that certain headers are routed to a certain deployment. But since there are so many presentations already on that part, I'm going to use a different approach. Before the demo, let's talk a bit about the development cycle, and then I'm going to show you how development can be sped up with Istio and Istio Workspaces. So when I started the Java development, a typical cycle would be that you do implement your code, that you write down your code, then you compile it, build it, put it on an application server, there you do some tests, see that something is wrong or that it goes in the direction where you want to do that, and then repeat that cycle till the time you are, successfully finished your task, then push it to a central repository, and then the CID CD pipeline kicks in and starts with the testing for production release. And since we are using more cloud native deployments or development, it means that we have some additional steps. So if we now look at the cycle, it contains still the code and the build part. The next part would be to create the container, to push the container to a container registry, to deploy our application, then to run a test, and then to do it again. But these are at least 3 steps more, which takes some time. And depending on your application, that could be some longer time. So it would be a great idea if we can just, skip that creating container, push that deploy, and just go back from build to test, so that we can really quickly see our results and modify our code and then build and test again. And because otherwise what's happening is if you're building and creating container takes some time, you might look at IBM Developer, which is always a good idea to see some new articles, to get a coffee, and till the time you are back, 20 minutes have passed. Or you get some crazy ideas that you might do some sword battles with your colleagues while your code is not only compiling, but it's pushed to the registry and deploying it. Another point that also might happen is if you run that code on production, you might run in a situation where you have a certain bug where you can't use your log files to see what's going on, and you can't really reproduce it on your local test system. So it could be something like this. So first you have a look at the log files, you see I can't really get it, and in the end you know that some error happens on production, but you don't really grab what's going on. And for this, some guys at Meyer started to build Istio Workspaces. So what Istio Workspaces is doing is, if you have an application or a production environment or test environment that is already using Istio for the traffic control, you can use that to place your application right next to an existing productive system. So you have your developer tests, and from a logical point of view, you put your application next to it and you are working in the production environment. And the nice thing is that normal users of that environment will not notice that something had changed. And also your hopefully your customers don't know that. So if we go to an example that I'm going to use in a demo, we might have a data plane which looks like this. So you have a customer service, you have a preference service, and your recommendation service, and all three are talking to each other. So if you hit the customer service, it will fetch some information from request and recommendation and prints out an index from the recommendation. If for some reason something goes wrong with Istio Workspace, what you can do is to put your application or your preference service, in that case, that's running on your local laptop right next to the preference service that it's running on production. So your laptop really behaves like it's running in the production environment. And also, if you send a request to the Istio Ingress gateway with a certain request header, then the traffic will be routed through the production environment to your local machine. You can access some backend services, get the data and route it back. And with this, you have the chance to get a better integration in system like production systems. And also you can test certain bugs that are only happening in production. And to come back to the reference that Marco and Sebastian were using in respect with games, what you do is you create something like a portal from your local machine to your Kubernetes in a cluster that's running in production. So all the things that are happening on your local machine will also be available in the production system and vice versa. Okay, so let's stop here for a moment and do a short demo. So hopefully, yeah, looks good. My, let's call it production system, looks like this. I've got these three services. I can see that the traffic is flowing from the ingress to customer to preferences and back. I've got some very simple Istio configuration, which contains from a gateway, which means that Istio will be configured that it takes the information from a host, that it accepts the request from for the host on a special port number. In this case, it's 80. And there is a virtual service, which is, sorry, I'm going to switch to the YAML, is using that gateway, takes, here we have a wildcard star, so it accepts information for all hosts. And if it gets the information, then it will take a request and forward that to a destination with a host customer. We've got a destination rule set up for the customer, which has just one label showing that we have one deployment for customer, and all the traffic will be routed to that deployment or to that workload, how it's called in Istio. And overall, we have these settings for all three microservices. So we have a virtual route for routing the traffic and the destination rule for defining where to route to. So far, so good. Now let's connect my local test system with the Kubernetes cluster and run an application on my local machine that it's like it's behaving, that it's deployed into the Kubernetes cluster. And for that, sorry, I need to switch to the command line. I'm going to execute a command from the Istio command line tool. I put that in a shell so that I don't put in any typos because it's a bit longer. So here I defined that I would create a development. that I'm going to use the deployment preference 1, that I'm going to use a port mapping from 8080 to 8082 locally, that this is my used Kubernetes namespace, and this is the HTTP header that I'm going to use to address my new local server deployment. And please start the Quarkus application with Quarkus dev, and meaning that each time that I change something in the Java code, the Quarkus application will be restarted and will contain the changed code. And also I'm going to listen to port 5002 for debugging purposes. The network error we can ignore, that's only happening on my local machine. And we can see here that my cluster is up and running. So let's go.
Olaf, just to verify, is this cluster being running on Kubernetes,
That's
or is
a
it running
Kubernetes
on
cluster.
OpenShift? Yeah, that's what I thought you said that, but I wasn't sure because we have been talking before.
OpenShift, I need to check that it's working as well. Okay, so let's have a look if something has changed in the Istio configuration. So if I look at the virtual service for the preference, I can see that it contains now a new section for matching an HTTP header, meaning that if I provide the IX session ID with the feature Y, it's not going to use the normal preference destination, but instead it's using a different subset, or that's going to be translated to a different deployment. So instead it's going to use the subset V1 Olaf 10. So the last part is always generated, so could be any value. And if we look at the destination rule for preference, let's have a look in the YAML. We can see that we have now 2 labels with 2 subsets available. So the first one is still there, V1, and the second one is version V1 Olaf 10. And this means that all the requests that are targeted to that destination will be redirected to workload where the version is V1 Olaf 10. So let's have a look at the workload. And we can see here we have a new workload running. And in a moment, I can show you that we have a new pod and a new deployment for that. If we look at the graph, hopefully, we can see that right now we just not have the version V1 of preference running, but also V1 Olaf. And this one here is really running on my local machine. So all the traffic that you can see here is forwarded from the Kubernetes cluster to my local machine, and the requests to recommendation from here are routed back to that Kubernetes cluster, and I get the response back, and so on. So let's have a look at my environment. So here is the source code of that REST service. So it's not really a complicated source code, and let's change something, because right now, if we look at the log files, they are printed here. You can see for the production part, it's showing customer preference recommendation V1, and we got a reply back. And for local, it looks the same. But let's change that. So if I now do some change here in the code, let's assume I fix a bug and save that. What will happen is that Quarkus will pick up that change, recompile, start the application again. And as you can see here, the second line has changed, and we've got right now V2 there. So we've modified the input. Let's stop my script that's hitting the ingress service and see if we can debug that service. And let's start my debugger. And as you can see, I'm here connected to the JVM. And I'm going to run, a local script called, where is it? Local application, which is just executing one curl command and not doing a loop. So if I hit that, you can see that I'm connected to that, or that I'm getting a breakpoint here. It's getting the response from the recommendation service. So we can see here, recommendation from that pod. And of course, I can have a look at all the environment variables. Or even in my case, I can just say, okay, I just want to change that and make that recommendation 99. And if I press enter and continue, you can see that that my log has changed, or the log output has changed. If I show you, I need to stop the debugger, what's happening in the script, it's really doing just a curl to the Istio ingress, and it's using just the session ID. So it's really, I'm talking to my Kubernetes cluster, and then the request is forwarded for preferences to my local system. And let's have a look at the pods. So I use for displaying of the pods the K9S GUI, and we can see here we've got an additional pod running for the new version. And if I now stop my local development, what's going to happen is that this pod will be stopped. The other pods are not impacted, and you could still get requests for the normal preference service, and everything works without any interruptions. And if we go back to the Kiali, which is more or less like a GUI for Istio, we can see that the virtual service has been reverted to the previous state. So I just have one route back to preference, and everything should work like before. Okay. And with this, I'm done with the demo. And I'm going to wrap up the presentation. So to put that, or to sum that up for service meshes, they offer a lot of possibilities, what you can do with the traffic, how you can look at the requests, how you can increase the security and the reporting. As a side note, I hear a lot of times that the service meshes take up quite some performance and introduce some latency. That is true. However, I haven't found any performancing report showing how long it takes if you would build that by yourself in Java code or Python code and compare that with Istio or other service meshes. And also, what I find the main advantage is you just need to modify the configuration. So you don't need to touch your application code, with one exception for the tracing to route through the tracing header. But besides that, all the changes that you need to do is really in the configuration. And this brings to the real, drawback of service meshes, since they allow a lot of possibilities, have a lot of configuration. It means also that they have an increased complexity. So it's not something that you could say, yeah, or what I wouldn't recommend is to use that on a running production environment with one big bang deployment, but I would introduce that granularly to add more applications to the service mesh to see how it's behaved, what features you need, what features you don't need, instead of to put everything in a service mesh with one goal, because it could be quite hard to find where the configuration is going wrong, where to find your setting, or where to find the log files in the proxy if something is not working like intended. Okay, you can find the link to the Istio Workspaces here. And if you find that interesting, you might also check out an application called Flagger, or a framework called Flagger, which is used for verifying deployments. So it's this way, or what it's intended for is after a canary deployment, it's going to check the canary, so to say, and compare whether this has similar performance numbers or similar error quotes than the current running version. And if this is the case, then it will be automatically deployed. The canary will become the current version. And if this is not the case, then the canary will be rejected and you need to have a look at the code to see what's happening. Okay, so thank you. And do you have any questions?
Thank you, Olaf. Actually, people were very active in the chat, and we have been able to answer most of them on the fly. Your presentation was just great. So we do not have any questions in the Ask a Question section. However, I can just emphasize on the point to, if you want to join our community or get in touch with Olaf or myself, connect with us on LinkedIn, and we are more than happy to to get in touch with you. And I'm really looking forward to work with you more often, Olaf. There's going to be a lot more tech talks.
Okay, great. Sounds fine for me.
Just let me have a last look at the chat. Oh yeah. So before I forget, if you like to give any comments or any feedback to us, I would be more than happy if you could provide feedback under the following link. Let me just post. Yeah. So yeah, the paste is working so great today. Okay. There's a survey you can do. So we are always happy for feedback, so we can improve in the future. And I wanted to mention, I did that in the chat as well. If you want to have a further look on app modernization and how to improve monolithics with cloud native development, our dev advocates Niklas and Thomas have created a very cool project, Cloud Native Starter, where we do a lot of the things Sebastian, Marco, and Olaf just talked about. And so that there you see how it all comes together, which is really cool. And with that said, for today, one more question, I think. Oh yeah, that's a cool one. So Olaf, Ali is asking you, have you measured the overhead of adding the proxy, and also have you tried other service mesh products and benchmark their performance?
So the second part, no. To be honest, I always wanted to do that, at least also for to see how it's working on OpenShift. I didn't have the time to do that. I know that there are some documentation comparing Linkerd with Istio, but I think it's a hard match, and it's really depending. You need to have the same configuration to compare them. I know that the guys from Istio always add to their latest version a page where they're showing how much the latency will be introduced if you just add the proxy, how much more does it cost if you use MTLS with the authorization and so on. So you would get a good overview what the memory consumption is, CPU, and also the latency. So that would be a part that I would recommend to check out for that. Also, I've seen some parts where some guys had a look at Kafka implementation and were comparing Kafka MTLS with TLS version using Istio. And there was some performance gain, at least, with an older Java version. So with using Istio, they were able to transfer more data to a Kafka broker.
All right.
And we can do a setup for the how to set up service meshes. No problem.
Thank you so much, Olaf. So yeah, stay tuned. I guess there's going to be more in the future. Olaf and the team and I are going to have a look at it. And for today, since we are almost on the top of the hour, I'm going to say thank you, Olaf, again. I really
You're very welcome.
Enjoy working with you. So thank you for being here and having this fantastic presentation. I shared the slides publicly on Box. Take a look. It's all in the chat. And for today, I'm going to say thank you, goodbye, good evening, good morning, whatever the daytime is where you're located at. Stay healthy, stay safe, and I see you soon in another session. Goodbye. I'm going to end the broadcast now.
Bye-bye.